When should an AI just trust the code it wrote, and when should it keep testing it? A new paper found a precise line for that, and following the line beat the usual just test everything approach by about 65 points, on a scale where one correct answer is worth 100.
Okay, before you explain, guess with me. Out of every situation you could put this thing in, how often is the clever version actually worth using? All of them? Half? Pick a number and hold it.
And hold on to one small detail too, Tyler. A single test that takes 11 whole minutes to run. That one detail decides the entire result.
So we're talking about those AI coding helpers, the ones writing and checking code inside the apps people actually build with.
Right, and here's what's coming. A test that's basically free but tells you nothing. A manager that never touches the workers, yet makes the whole team smarter. And a map with 3 zones that says exactly when being clever is worth it and when it's a total waste.
I'd bet most people assume a better coding agent just means a bigger, better trained AI.
That's the natural guess. More training, more smarts. Except nothing here got retrained, not one model. All the new smarts live in the manager, the part that decides what to do next. So picture a doctor deciding whether to order one expensive, definitive scan. The doctor keeps a running hunch. I'm maybe 40% sure this patient is sick. Cheap, quick tests nudge that hunch up or down. The pricey scan gives the final truth, but it costs. That's how this control layer treats code. The hidden question is simple. Will this code pass the real, final test, yes or no? The manager keeps a running probability. Cheap checks nudge it, and the expensive final test suite, the 11-minute one, is the definitive scan.
So how does it decide when to pay for the scan, Bella?
One clean rule. Run the expensive test only when your confidence, times the payoff for being right, beats the cost of the test. If you're barely sure and the test is pricey, don't bother yet. Run a cheap check first and sharpen your hunch.
And they actually tried this?
They did. 6 different AI coders, 9 sets of coding problems, including real bug fixes pulled from actual software projects. The probability tracking manager running on top of frozen models against the plain fixed rules. But whether it won came down to one thing, that 11-minute test. Keep it in mind. Because when they mapped every situation, 3 zones appeared. When the final test is cheap, a second or two, just test everything. The clever manager is pointless. When one quick check is almost as good as the final test, just trust that check. Again, no need for anything fancy. But when the final test is slow and expensive and no single cheap check settles it, that's where tracking a probability wins. Right there, it beat test everything by that 65 out of 100.
Wait, so the smart version only helps in one of the 3 zones?
One corner of the map, Tyler. That's your answer to the guess you made. Not every situation, not half, just the messy middle. And the 11-minute test? That's the whole reason that corner exists. On real GitHub bug fixes, the final check really does take 11 minutes, so you can't afford to run it on everything. That's exactly where a running probability earns its keep. On easy problems where checking takes a second, the whole idea is wasted effort. And remember, nobody retrained the AI to get this.
Though that 65 is flattered a bit, test everything is set up to lose when tests are that pricey. Against the fairer opponent, just run the one good check. The smart manager still wins, but by a lot less.
Fair. So here's the one to chew on. If an AI were writing code for something you rely on, would you want it to keep interrogating its own work? Slower but surer, or trust itself and move fast? If you like AI research pulled apart in plain language, subscribe and join a growing crowd of curious people doing exactly that.
When should a machine stop trusting itself and go check?